In question number 8, shows the graph of a velocity versus time for a particle going along the x-axis. This one. We need to find the acceleration, and second be the distance traveled in 0 to 10 seconds and the displacement in 0 to 10 seconds. So let's do the first part. The acceleration should be easy. What is the acceleration? It's the change in velocity divided by change in time. We'll do it right here because it's an easy problem. Now the change in velocity is from 2 to 8 meter per second. So it is 8 minus 2 is 6, and divided by the time taken for this change is 10 seconds. 6 by 10 or 0.6 meter per second square. This is the answer to the part A. All you need to do is find the slope of this line. Now in the part B, we need to find the distance traveled in 0 to 10 seconds. So the distance traveled you can find by finding, let's say, what is happening on the x-axis. This is an x-axis, and let's say this is origin, and this is the positive x-axis, and this side is the negative x-axis. Initially, the particle has a velocity at t equal to 0 of 2 meter per second. So it starts moving with this acceleration, this velocity in this direction. And then let's say at 5 meter, it is somewhere here. It has traveled a distance of this much, which is given by the area of this curve. And then at 10 seconds, it keeps moving along this x-axis, in the positive axis. It does not return back at any point of time. It would have returned back if it had a negative acceleration at some point of time. So both the distance and the displacement are same along the x-axis, and they will be, the B and C will have the same answer because the particle keeps going along the positive x-axis in the same direction, and the distance as well as the displacement both will be same as given by the area of this curve under this, and that will be given by the area of this one, which is 10 into 2, which is 20, plus half into this triangle area, which is half, into 10 into this height, which is 8 minus 2 or 6. So this will be 3, 10 into 3 30, plus 20 is equal to 50. So 50 meter is the displacement. From here the particle will be at a distance of 50 meter at the end of 8 seconds. And this is the displacement as well as the displacement as well as the distance travel. If the velocity would have gone negative at some point, then that means that the particle would have come back at that point of time. The displacement would have been different from the distance.